right, so we talked about this problem just a little bit last time. This is 2.5, number 15. But I think the recording got cut off, so there were some kind of standing questions. All right, so for one thing, if we hit this with the test for exactness, we find out that this is exact. So that would be checking that, let's see, if we thought about this one as M and this one as N, the test for exactness is what, guys? It's M something equals N something.
N partial y equals n partial x.
Okay, perfect. So the y partial of the first thing is the x partial of the second. And really, who's due the test for exactness? Which French guy?
Claro.
Good. Cool. All right, so we kind of channel the ghost of Claro here. We find out that this thing's exact. And then we think to ourselves, okay, so there is some kind of function f that has these as, this is fx here, and this one's fy. Okay, so there is a function f like this, and then I get two choices. I can either integrate all of this crap dx, or I can integrate this crap dy, and then I need to sort out maybe some constants or something at the end here. But the important thing, I think, is that you get a choice, and you should pick whichever one's easier. In the case of looking at this, I'm seeing a lot of, there's a lot of terms on this side, and one of them is an e to the x squared, which kind of scares me, integrating with respect to x. Is see that concern? I don't know that it's impossible here, it's just probably annoying. So over here, if I'm looking at this thing, I'm seeing, oh, well, e to the x squared is scary, but if I integrate dy, then this is just a straight up u sub and isn't so bad. So that's the choice you want to make. But if you wanted, if for whatever reason you had to do this other thing, you'd need to be integrating, that's going to be 2x to the fourth e to the x squared plus y. And again, this is not a good idea. Plus 3x squared e to the x squared plus y plus 4x. And I need to integrate all this dx. Bad idea. Do the other one. Still do the other one. Have I said do the other one? You should be doing the other one, not this one. But which one? That's right, the other one. So if you had to do this one, your choice would be to say, okay, so I'm going to let u be x squared plus y, and I'm going to let u be x squared plus y. And that's not going to work in either case. You guys recognize that?
Mm-hmm.
Kind of shit out of luck. So what I'm going to have to do is some kind of funky integration by parts, which you can do. This is not impossible. So if you thought about doing these u substitutions, you'd notice pretty quickly that your du is 2x, right? And that's fine. I've got an x. I just don't have a 2x. Well, okay, so I don't have the 2. Big deal. But I have this extra x in here that's kind of kicking around, making me feel weird about everything. And over here, it's even worse. I've got an x to the fourth. You guys on board with that?
Mm-hmm.
So if, for whatever reason, you had to do this, the right technique here would be to say, I'm going to take this thing, I'm just going to walk over here, and I'm going to integrate x squared e to the x squared plus x, e to the x squared plus y. Just do this part by itself, right? So that shit's too complicated. I'm going to step over here and do a piece of it. The piece of it I'm going to do is I'm going to do integration by parts. And this is where everything gets real weird. So you have to pick a u and a dv, right? What's the philosophy for u's? When you're doing integration by parts, how do you pick these two things?
Ones that are easy to differentiate.
Good. Yeah, you need, for DV, you need something you can integrate, right? So I have to be able to integrate DV. If I can't integrate it, then I'm just doing this, like spinning my same wheels in a different way, right? All right, so the U is something that should ideally be easy to differentiate and preferably will go away if you differentiate it. So looking at this thing and thinking about my integration by parts, I feel like I'm probably going to make dv x e to the x squared plus y, because I know I can integrate that. That's like the bare minimum thing I can integrate. You guys with me on that? And then the thing that's going to go away when I differentiate it is going to be what's left here. So that's going to be an x. And then du is going to be dx. You guys on board here? And it should be noted I'm not completely sure this technique's going to work. You guys with me on that? Like, I'm trying something. This is my best stab at this. The right answer was still to integrate the other thing. Do you have something, Sam?
No, sorry, that was a misclick.
I was going to ask if anyone remembers the mnemonic device Jim taught us to integrate by parts efficiently. It was like something like doing trig first, or I don't know, like doing trig functions as a U.
Yeah, usually it's polynomials go in for u's, trig functions go in for dv's, exponentials often go in for dv's. It is a little bit seat of pants. Like, it is. There are a bunch of mnemonics you can look up, but I've never found that any of them works in every case. And so I tend to lean away from them and just say, like, you want to pick something here that you can integrate. You want to pick something here that you are going to get rid of upon differentiation. And you also want to be prepared for this to not work, and you have to try something else. All right, so if I integrate dv here, I'm going to do that by a quick little like w substitution in the margin, right? So w is going to be, w is going to be x squared plus y, and then dw is going to be 2x dx, right? Okay, so I need a 2 in here, but I can't just willy-nilly do that, so I need an over 2 here. With me on that? Okay, so in integrating this, I'm going to get a v, which is going to be e to the x squared plus y over 2. And then I should just check that this worked, right? So I'm going to get, if I differentiate v, I get e to the x squared plus y times 2x. And so the 2's cancel them. Okay, that worked. You guys all with me on this? And then I'm going to say, all right, so this thing then is uv. So it's x e to the x squared plus y over 2 plus, and here, oops, not plus. Oh, sorry, my handwriting's wandering all over the place today too. So I've got uv minus, and here I should have the integral of v du. Oh. And I'm noticing that I may have screwed this up. Okay, see this? So what happened?
There's nothing you can do to integrate e to the x squared plus y dx.
Yeah, it just didn't work. That sucks. Better idea? Well, okay, so philosophically, what do you do when integration by parts fails?
Cry.
Yeah, that's pretty fair. Like, yeah, you spent a bunch of time on this. It didn't work. One of the things I do want to maybe like the reason that I kind of delved into this morass knowing that it's the wrong way to do this problem is you guys see me do a lot of math and I kind of know what the right pathway is. And so you don't often see me like get way off into the fucking weeds because I try to avoid doing that in class time because I mean it's a little bit disrespectful of your guys' time for me to just wander around trying to figure out what the fuck to do. That said, it's also an experience that you guys have, right? And I maybe shouldn't become like it is probably a little bit dishonest for me to present that I don't ever have that problem. You guys with me on that? Like, honestly, yeah, Wolfram Alpha. Yeah. So, honestly, on this problem, like, this technique didn't work. I'm not super sure how to do this. So, I think what I'd probably try to do is, like, let's see, what else could I do? Like, what would my other choices be here? What would my next steps be? Like, Wolfram Alpha? That's fair. I might try to see if this thing has an antiderivative. Let's see. And you guys were nice enough to provide a link that I can. Okay, so this one's not quite what I'm trying to integrate, though, right? I'm trying to integrate this. And I'm trying to integrate x squared e to the x squared. Oh, crap. Yeah, this one doesn't have a closed form either, which is a little weird. You guys see that? What was the rest of that thing? So the rest of it was this 2x squared plus 3. So maybe the deal is just that I needed that? Oh, see, that's friggin' cheating. You guys see that? You needed the whole damn thing. How was I supposed to see that? Well, if I'd integrated the other one, I would have seen that. The other thing, right? And the kind of the reason I wanted to talk about this is, if you're doing a problem in real life, yeah, fuck yeah, use Wolfram Alpha. Like, try it, see what happens. Sometimes it's that you've broken it into too small of pieces. Like in this case, the issue is when I multiplied this out, right? I just got some crap that wasn't going to cancel. If I had left it all together, maybe I would have had a better chance of integrating this thing. You guys see me? Okay, so philosophically, what we should do is integrate the other one. But also don't be afraid to be frustrated. Like if it doesn't work, you don't have to give up though. You can be frustrated for a second, walk away, and come back. You guys all good with that? Cody, if you could write this one down as philosophy of frustration, that might be useful. One of the things not to forget, guys, is math problems are not fundamentally about knowing what to do. They're fundamentally about being presented with a puzzle you don't know how to solve and persevering in the face of that. Like the reason that we teach you differential equations in engineering is not necessarily because you're going to use differential equations every day in engineering. Like you might. Odds are you won't. The odds are that the skill we're imparting for you is thinking about rates of change, thinking about mathematical models, having some persistence with symbols, and a little bit of that problem solving persistence of just like, I don't know, I'm going to take a stab at this, and if it doesn't work, it doesn't work, and then we'll take another stab at it. If that's all you take from this course, you will be a better engineer for it. That said, I'd like you to be able to build, bridges. And building bridges takes differential equations sometimes. Other questions on this one? Okay.